Today's session we will be discussing about the unit 1.1 of the solar panel installation handbook for technician. So unit 1.1 consists of the basics of electricity and power generation system. So this is the basics of the electricity. Why? Because our solar panels, they are dealing with electricity. Okay, so it begins with the basic terms used in electricity like the current, the voltage, power, energy. Okay, now first of all, what is electricity? So basically electricity, that is a natural force, okay, that comes into existence whenever there is a flow of electric charge between two components. Okay, so when working with circuit, now here a term is circuit. So what is circuit? Circuit is basically a combination of some elements. Okay, so elements can be anything. It could be any conductor, it could be any source. So they are connected together, it forms a circuit. So in a circuit, there is a need for the users to be aware that about some of the basic concepts. So basic concepts are current, voltage, power, energy. So current, what is current first of all? So the electrons inside any material, they move and they form a current. So basically current is the movement of electrons. So it is in a particular direction, and the unit of current, that is ampere. Next thing is the voltage. So in an electrical circuit, okay, the current flow that takes place in a particular direction, which I said, there is direction from a higher voltage to the lower voltage. So basically voltage is what? That is the force which is pushing electrons through the conductor. Not only conductor, any medium. Okay, so most probably here we will be dealing with the conductors, any type of load. Okay, next thing, that is power. Okay, so when electricity flows in a electric circuit, so some type of work is done. Okay, so what can be the work? So some of the examples, like a fan, the fan is moving, it is rotating. Okay, so similar, this is the work done. Then in a refrigerator, the cooling is taking place inside the refrigerator. So this is the work, it is being done by electricity. Okay, so whenever electricity flows through any appliance, some type of work is done. Okay, so the rate. Okay, so the rate at which an electric circuit transfers electric energy. Okay, this is called as electric power. So what is the rate first of all? Means the quantity, the energy here that is changing, and it is being measured with respect to time. So this is the rate, that how this thing is changing, the energy is changing. So electric power is similar to mechanical power and can be considered as the rate at which electric work is done. Okay, so the unit of power, that is watt. So here the mathematical expression is there. P, that is equal to work done then per unit time. So what is it? We are measuring the work done with respect to time. So work done per unit time, that becomes a power. Okay, so another, mathematically we can express it as a product of voltage and current. Now, in fact, what is current? Current is the flow of electrons. Okay, so Q, that is the charge with respect to time, that becomes current. So Q upon T, we can write I as Q upon T. Okay, next. Okay, next thing is grid. What is grid? So electric power that is being produced by electric generators in a power generating unit. Okay, this unit, that is a grid. Means a grid, we are having this power generation. Then this power that is generated, that is supplied to the load. What is the load? Where the power is being consumed. So residential load could be there, commercial load could be there. Okay, so generator is not the only source to produce electricity. Other sources which are used, like the battery. Okay, and how much energy is delivered, how much it is consumed by the load. Load could be like our house itself is a load, electricity is being consumed there. So it can be measured by using an energy meter. So same energy meter which are being installed near the load centers, like the meter which is installed at our household. Okay, next thing is energy. So if the electric power is the rate at which the work is done, then energy is the total amount of work done, okay, in any given time period. So what does that mean? Total work done in a time period. Okay, so what does that means? That power multiplied by time. It was time period into work done. Total work done, that is power in a time period, to multiply by that period, then we get the energy. Okay, so here the mathematical expression for energy, that is equal to power into time, or power is equal to energy upon time. Okay, so they are interrelated, energy and power. So unit of energy, okay, we will come to it in our coming topic. Okay, now Ohm's law. So what does Ohm's law states? That with physical conditions remaining same, current flowing through any conductor is directly proportional to the voltage across the conductor. So mathematically, I, that is equal to V upon R. Okay, so current is proportional to voltage means as the voltage is changing, the current is also changing by the same proportion. To remove this proportionality, make it into equality, we use a constant. That constant is the resistance. So resistance is what? Basically, it is just an obstruction in the flow of current. Now, coming to the next term, electric circuit. Okay, so okay, that I have discussed interconnection of various elements, various components. They form a circuit. So it could be any source. So battery, that is a source. A conductor, a wire. Okay, switch, that is an element. Load, that is an element where the power is being supplied. Okay, so here in the figure, the load is shown here. First of all, there is a battery or the power supply, the switch, the load. In the next one, there is a battery, there is a LED lamp. Lamp is what? It is a load. Battery, that is source, it is supplying power to the lamp or the load. Okay, so electric power that flows in two forms. First of all, it is DC power, and one it is AC power. So DC power or the DC power, that is basically it is constant. It is in the same. It is having the same magnitude, and it flows in only one direction. Means there is no change. It is fixed. Every time it is the same. Okay. In case of AC, okay, the current, AC current or AC voltage, that is alternating current or alternating voltage, that alternates with time. It means it is never, it is constant. It is minimum, it increases, then it goes to a maximum value, again decreases, becomes zero, then reverses its direction, flows in the opposite side, then increases, then comes to zero. So here in the figure 1.1.2, the red line that shows the direct current, whereas the green curve that shows the alternating current. So how many such type of changes the current makes in 1 second? That is the frequency. So what is the frequency? Standard frequency in India, that is 50 Hertz. Means in 50 times the current is changing. Next, series and parallel circuit. Okay, so elements like in this case it is a lamp. They can be connected in series, means one after the another, and the current that is following through a single path. Then all of those elements, they are connected in series. Okay, like in 1.1.3, the first case, the series circuit. Two lamps are there and they are connected in the same path. Same current is flowing through both of them. Then they are connected in series. Okay, on the other side, on parallel circuit, both of the components, they are connected in parallel. How they are connected in parallel? Their endpoints of both of these elements are connected to the same point. Means the current is dividing between these two elements. Okay, so in a series circuit, current is same, voltage across both of the elements are different, whereas in case of a parallel circuit, the voltage across both of the elements are same, but the current is different. Okay, now how to measure the different parameters: voltage, current, resistance. for the measurement of these quantities, the two type of multimeters. Multimeter name suggests multi, then meter means many quantities. This multimeter that can measure. So what two type of multimeters are there? Analog and digital. So analog, there's a pointer is there, it moves to a certain value. Okay, on the other hand, digital multimeter, their pointer is not there in the display, numeric value displays. That becomes a digital multimeter. Okay, next, different type of quantities, AC voltage, DC voltage, AC current, DC current, resistance, all of these quantities can be measured by using a multimeter. So how we used to measure it? Check the connecting probes or the wires, black and red colored wires. Okay, we have to put it on the terminal where we want to measure the quantity. Okay, then switch off the knob. The knob is in the center of the multimeter. Switch it to the related quantity. You want to measure the voltage. So take the knob to the voltage. Put the wires across the 2 points where we want to measure the voltage, and in the display we will get the voltage. Similarly, we want to measure the resistance. Okay, here in the diagram, the measurement of DC voltage that is shown here. So the black and red colored cables leads, they are connected to the terminals of the battery, and it is showing a voltage of 4.81 volt. Similarly, in this case, 236 in the second diagram, 1.1/6, the 236 volt, this voltage is present in the terminal of the socket shown there. In case of resistance, just connect the two terminals of the resistance with the two leads, black and red color lead. Twist the knob, take it to the resistance side, and here 11 that is being displayed. Now how to measure power? Just measure the voltage, measure the current, and multiply them. Now how to measure the electricity energy, electric energy? Here we need an energy meter. So very common this one, the diagram 1.1.8, the analog or the the induction type energy meter that is shown here. Currently it is not used. In a very few places it would be still be remaining. Otherwise everywhere electronic energy meters are being used. Okay, they directly show the energy consumed. Okay, now power generating system. So it consists of three phases: power generation, power transmission, and power distribution. So power generation takes place by using different type of energy resources. So different type of fuels, nuclear, it could be coal, it could be hydro. So this type of fuels, they are used to generate electricity in a power plant. This energy generated, that is transmitted to long distance using a transmission network. The transmission network is shown, transmission tower is there, transmission lines are there. After that, another substation is there, which is making the power level suitable for the consumer. Further, this power is fed to the consumers. Okay, so here a small activity is given. So missing values in the table. Okay, here two values are given: voltage, current, and power, and different components: fan, LED, TV, refrigerator, motor. So two quantities are given, and we have to find out the third quantity in every case. So it is simple. We have to use the relation power P is equal to V into I. Okay, all of them, they are DC load. So just use the relation P is equal to V into I. Two values are given. In the case of fan, 12 volt is given, 2.5 ampere is given. How much power? Just multiply these two. 12 into 2.5, 30 watt. Okay, next, LED. Volts are not given, current is given, power is given. So voltage V is equal to P upon I. Okay, so how much it will be? It will be 1.5 divided by 0.5. So 3 volt. Okay, similarly we can determine the other quantities. Now the second case. Here we have to determine the energy. So what is energy? Energy is power into time. So here P into T, that is the total energy. So different components, tube light, okay, another tube light, fan 1, fan 2, TV, cooler, computer, LED light, then AC, 2 AC, and some unknown appliances. They are given, we have to determine the energy. So in the first case, 40 watt power is given, time is given 4 hours, just multiply them, 40 into 4, 160 watt hour. Okay, in another case, 40 watt power is given, but the tube light, second tube light, time is not given, energy is 400 watt hour. How to find out the duration or the time? Just divide 400 watt hour energy by the power. So 400 divided by 40, that gives 10 watt hour. Similarly, in case of fan, 60 watt for 12 hours, multiply these two, 480 watt hour. Okay, similarly, we can proceed for all other elements as well. So in this way, we can calculate the energy. Okay, so we should stop.